Good morning. Today we're going to continue with the handout. I suggest you review or rewatch the video, pages 251, 252. But today we're going to talk about the meat of the handout, if you will, Miller Motor Company. Remember first thing is the formula is right there that you have to memorize for sample size. I get frustrated. I think students focus so much on the statistics part of this that they lose sight of what's easy. So the night before the test, you can memorize the formula for sample size. The most common mistake is in the denominator tolerable misstatement. That's the average tolerable misstatement. So that's not in our handout. It's not the 200,000. It's the 117 average. The issue, as we talked about on this video for 251, 252, the projected misstatement from the sample is the auditor's best estimate of the misstatement in the population. We have to project our sample findings to the population. As the projected misstatement approaches tolerable misstatement, it's more likely the actual misstatement in the population exceeds the tolerable misstatement. So we'll go through that in the paper. The question is, how close is too close? So the last page of the handout is made to tear off. And there's another copy of it in the work paper, so don't worry about that. But it may be helpful to follow the presentation if you have it. So just tear it off. Now fold it. There's a dotted line there in the middle, and you fold it along that dotted line, and that's what our client presented to us. So the left hand is what the client presented to us. Now, notice on there we've got line 1, 2, 3, 4, 5. It skips 6 to 983, and then we've got some 990s, and it skips from 991 to 1700. So in our make-believe world, Miller Motor Company has 1,703 SKU numbers, part numbers in their inventory. Notice we're going to audit by part number, not individual parts. So the very first line, they have 5 tail lamp bulbs, but we're going to audit by the part number 4470312. And that helps reduce our variance, which will reduce our sample size. Parts inventories and lots of inventories tend to have more of the less costly items and fewer of the more costly items. So when we audit by SKU number, we tend to reduce the variance and the sample size. Now, notice the extended cost of the inventory is $1,965,560. And if we take the standard deviation of those items, it's 861.52. So as we plan the audit, those are the numbers we have to work with. We don't have our audit results yet. So we're going to use the information from their books. And that is the book value is 1,965,000 and the standard deviation is 861. They have the retail price here, but what we're really worried about is cost. We report inventory at cost or lower of cost and net realizable value. So in this case, we might actually, not in this example, but in the real world, we might use the retail price to figure net realizable value. In this example today, we're not going to have any need to work with the retail price. We're just going to worry about cost. Now, the right hand side of that sheet are the audit results. So we took a sample of 387. Uh, we won't get around to where that number came from for a while, but trust me, we took a sample of 387. The extended cost of our sample was $441,567. We can divide that by 387 to get the average, 1141. So our sample average is 1141. And the standard deviation of the items in our sample is 880, a little different and more than the standard deviation for all the items, the book values. Notice once we find a mistake, then the standard deviation from the book values is wrong. Maybe just a little tiny bit wrong, but as soon as we find a mistake, that will not only change the extended cost of the book value, but it will also change the standard deviation. So just out there. Now, we're going to find two kinds of errors. So spark plugs there, they say they have 240 of them. We went out and counted, they only had 239. Does that seem like a reasonable? Yes, but that's going to change the extended cost. Okay. The second type of error we're going to find is cost. So these steel wheels, they say they cost $132.92 a piece. How are we going to audit the cost? With quantity, we can go out in the warehouse and count these 387 items. While we're out in the warehouse, we've got some other auditors going through the purchase invoices to see how much they actually paid for these items. And when we go through the purchase invoices, these steel wheels cost $123.92. Oh, is that a typical transposition? Yes. So they actually cost $123.92. Somebody reported it as $132.92. Those are the types of errors that we found in when we took our inventory. So the quantity and the cost can both be incorrect. The book values $1,965,560. The standard deviation of the extended cost. Now, what's it mean, extended cost? That's where I take the quantity times the cost. Remember, we're doing SKU, so the quantity is typically more than one. So extended cost just means I take the quantity times the cost. The partner tells us tolerable misstatement is $200,000. So that's about 10% of book value, isn't it? So instead of 196,550, he just says, let's use 200,000. So inventory will be materially overstated if the actual value of inventory is less than 1,765,560. We know that auditors aren't required to prove the account balances are perfectly correct. They can't be materially misstated. They have to be fairly presented in all material respects. So we're saying as long as inventory exceeds 1,765,000, then it's fairly presented in all material respects. Now we're going to bounce back and forth. So the book value is $1,965,000. We divide that by 1,703. The average book value is $1,154. Tolerable misstatement is 200,000 divided by 1,703. Then the tolerable misstatement for our average on average is 117.44. Because we're taking a sample, we're going to try on our sample results to prove that the true value proves too strong a word, to provide evidence that the true value exceeds 1,036 for our sample, for the average. Okay. Notice that these are the same numbers, they're just divided by 1,703. So don't get confused when we move back and forth. Here's a slide from the page 251 if you like that better. So the book value's $1,965,560. It's overstated if it is less than $1,765,560. We divide by 1703 for our averages, and we get an average book value of 1154. Critical value of 1110. We'll get into that later on. And the book value minus tolerable misstatement, what we're trying to prove. We want our sample to provide evidence that the average exceeds 1036. This is just presented if you're comfortable with what you saw on page 251, 252 in that video. Notice here, we've got a bunch of sample means. We're just going to pretend. If our sample mean was 1154, that means there's almost no risk that it's overstated. X2, as we move to the left, as our sample mean moves to the left, and if we get a sample mean of 1141, there's a little risk that the book value might be overstated by 200,000, but it's really pretty small. Now, as the sample mean gets smaller, moves further from the book value, then the risk of overstatement increases. Does that make sense? If the sample mean was 1060, X4, way out, then the risk continues to increase. Hopefully that makes sense, that the further that the sample mean is to the left of the book value, then the greater the projected error, the projected overstatement, and also the greater the risk that the inventory is overstated by $200,000. Now, if our sample mean is 1036, then there's a 50% risk that the book value is overstated. Now, think about that. Why is it 50%? And we'll come back to that in a minute. Table 2 is the same thing. Notice the sample means are 1154, 1140, the same 5 sample means that we just talked about. But what we're going to do in table 2 is, instead of measuring the projected error, the distance between the book value and the sample mean, instead of starting from the book value, we're going to start with what we're trying to prove, our hypothetical mean. We're going to take the book value minus tolerable misstatement, 1036 in this case. So instead of measuring from the distance from the book value to the sample mean, we're going to measure the distance from the sample mean to what I call the hypothetical mean, what we're trying to prove. Okay. Do you see it's the same thing? We're just measuring from the left to the right instead of the right to the left. Okay, so in the first case, if we get a sample mean of 1154, X1, the difference between our sample mean and the 1036, what we're trying to prove it's greater than, is very large. Now, we can use statistics to determine the X1 is 2.63 standard deviations to the right of the 1036, what we're trying to prove it's greater than. And the probability of getting sample results 2.63 standard deviations to the right is less than 1%. Now, the 1141, we measure that's $104 to the right, $104 greater than 1036. That's 2.33 standard deviations to the right of our hypothetical mean. We can look at the tables and see that there's a 1% chance of getting that. I guess I goofed up here and started the wrong direction, so shame on me. If the sample mean is $10.94, then that's $57 greater than the 1036, and that's 1.28 standard deviations. The tables will tell us the probability of getting a sample mean 1.28 is 0.1. So we're taking these same 5 sample means, but we're looking at them as how much greater they are than what we're trying to prove. What we're trying to get evidence that the true mean is greater than 1036. Okay, so the same 5 sample means, but now if we start from the hypothetical mean, we can calculate the probability that we could get a sample mean that large from a population with a mean of 1036. Okay. Make sure you understand that if we take a distribution around 1036, half the sample means will be greater than 136. So if our sample mean is 1037, that's not very persuasive, because even if the inventory had a balance of 1000, average balance of 1036, we would expect half the samples that we would select would have sample means greater than 1036. Okay, so here's the same. We're going to compare. So the upper chart is based the distribution around our book value of 1154, and the bottom is centered around 1036. Now, we're going to have a critical value for statistics someplace in between those two. And what we learned from page 251 and 252 is the distance between 1036, what we're trying to prove, and the critical value is our allowance for sampling risk. Okay. X5 may be greater than 1036, but it's not very much greater. It's not very persuasive. X4 is greater than 1036, but it's not very persuasive. X3, oh, we're getting close. Is it persuasive? I don't know, not quite. X2, yes, that's persuasive evidence. This is just table 1 and table 2 side by side, but off to the left we have our z-scores. When you took statistics, you learned you had a z-table, possibly a t-table, but for larger samples, the t and the z become the same. Okay, so our sample results were 1141. Our projected misstatement is 22,437. Is that close to 200,000? No. Okay. Can we be comfortable? Yeah, we could probably just stop there and say, well, that's nowhere near 200,000. I'm comfortable. But our partner, remember, our partner has a lot at risk here. Partners are liable, personally liable, for the audit results. So he doesn't want us to screw up, and he tells us that he wants us to be 95% confident in our results. He wants the risk to be less than 5%. So we can look down at table 2, and table 2 we've got the same 1141, but here we're going to compare it, instead of comparing it to the book value to see what our projected misstatement is, we're going to compare it to our hypothetical mean of 1036. That's $104 greater. We can use the standard error, the standard deviation, to calculate how many standard errors that is to the right of our hypothetical mean. It's 2.33. Then we can look on the table to the left and say, gosh, if the inventory had actually had a balance of 1036, if the average inventory balance truly were 1036, the probability of getting a sample with a sample mean 2.33 standard deviations greater than 1036 would be 0.01, 1%. So we're really comfortable. Okay, here's our sample results. Now notice the sample standard deviation is greater than the original. I'm going to use the greater just to be conservative. The larger the sample size, the larger the standard deviation, the more conservative I'll be. Okay, so here again, putting this in the same format as we did for 251, we can see that our sample mean is really close to the book value. I'm comfortable. There's no problem. I think we've been through this before, so we've got a 1% risk. Partner wanted 5%, so we're great. We're over 95% confident. Be familiar with these tables. You'll notice that the table on the right is the beta risk is hypothesis tests are typically one tail, confidence intervals are typically two tail. So if we look at any one of those lines, we'll see that it's typically, or pardon me, it's exactly twice as much. Thank you very much. The next video will continue with statistical sampling. Got to work on my spelling there, don't I? And I think it's going to be over work papers. So thank you very much, and I'll see you tomorrow.